Hello students. Today I am going to discuss fundamental concept on nucleophilic substitution reaction. Now what is nucleophilic substitution reaction? The name implies that nucleophile is going to substitute something. So what is going to be substituted? So here we have taken one example. This is one alkyl iodide which is reacting with water molecule. Now here water is acting as a nucleophile because oxygen has two lone pairs. Now this carbon iodine bond will break and here a positive charge carbon will generate, which is called carbocation. So here carbocation is acting as a electrophile. Now nucleophile water will attack the electrophilic carbon center. Here nucleophilic center is oxygen. So attack will be occurring via oxygen to positive charge carbon. Then we are getting this intermediate. Here oxygen will be positive because one lone pair is donated to C+, which is used to make this new bond, carbon oxygen bond. So that's why O become O positive. Now deprotonation will take place and we will be getting alcohol. So here you can see that iodine, this iodo gets substituted by a nucleophile water and we are getting a new compound alcohol. So this is called nucleophilic substitution reaction. There are two types of nucleophilic substitution reaction, SN1 and SN2. SN1 means substitution nucleophilic unimolecular and SN2 means substitution nucleophilic bimolecular. These unimolecular and bimolecular terms are related with chemical kinetics. When a chemical reaction takes place and the rate determining step depends on the concentration of only one molecule, that is called unimolecular, and when it depends on the concentration of two molecules, that is called bimolecular. Let's understand SN1 mechanism. So here we have taken one alkyl halide, this is tertiary butyl bromide, and we have taken methanol. Here methanol will be acting as a nucleophile and oxygen is the nucleophilic center because it has lone pairs. Now bromine is a leaving group, so carbon and bromine bond will break. So when carbon bromine bond will break, we will be getting carbocation, positively charged carbocation. And this carbocation is 3-degree carbocation because C+ is connected with 3 carbons, so it's a 3-degree carbocation. And carbocation is acting as an electrophile. Now nucleophile will attack. So nucleophilic center is oxygen here. So we are getting this intermediate. Since this lone pair is used to make a bond with carbon oxygen, a new bond. So now oxygen become positively charged. Now this hydrogen will leave, deprotonation will take place and we will be getting this compound. So Br leaves and a new group came here, that is OCH3. So for SN1 reaction, formation of the stable carbocation is important. So here you can see in this reaction a 3-degree stable carbocation forms. So this is an important part and this is the RD step or rate determining step. And in second step, nucleophile attacks. So second step is the first step. So nucleophilic substitution reaction rate depends on the concentration of this substrate. It is not dependent on the concentration of nucleophile. So since in the RD step, rate of the reaction depends on only one molecule, that's why it is called unimolecular reaction. Let's explain nucleophilic substitution reaction SN2. To explain SN2 reaction, there are two molecules have been taken. This is ethyl iodide and water. So water molecule will be acting as a nucleophile. Now this iodine will be acting as a leaving group. So when iodine will leave, we will be getting CH3CH2 plus this carbocation. This carbocation is 1 degree carbocation. It's a highly unstable carbocation. Now in SN2 reaction, the leaving group leaves and nucleophile attacks happen together. What we have seen in the SN1 reaction, leaving group is leaving and we are getting a stable carbocation. This is the first step. Then in the second step, nucleophile attacks. But in SN2 reaction, leaving group leaving and nucleophile is attacking at the same time. So that's why it has been shown like a dotted bond. Like dotted bond means leaving group is leaving, at the same time nucleophile is attacking. So this is called a transition state. Then completely iodine will be leaving and OH2 will make a new bond with the carbocation and will be getting an alcohol molecule. So here you can see that iodo, the leaving group, which is substituted by a new group, that is OH. That's why it's called nucleophilic substitution reaction. And why it is a bimolecular? Because rate of the reaction depends on the concentration of both substrate and the nucleophile. That's why it is called bimolecular reaction. Now important point in SN2 reaction is that here reaction takes place in one step, like leaving group leaving and nucleophile attacks happen together. So it's called concerted process. And nucleophilic substitution reaction of SN2, the carbocation stability is not an important factor. So now what is the criteria for SN1 and SN2 reaction? So this is the reaction is a characteristic of aliphatic compounds which is connected with some leaving group like OH, Cl, Br, like this. And the compound should be definitely aliphatic compound. Here you can see the carbon which is connected with the leaving group. These are all sp3 hybridized carbon. Now here we have taken another example, bromobenzene. So here carbon is connected with bromine. So if you think that bromobenzene, this bond will break and you will be getting a carbocation, then it's not going to happen. Because this carbon is sp2, it's not sp3, it's a sp2 carbon. So when the leaving group is attached with a sp2 carbon, it cannot break and form a carbocation. In this case, if the carbocation form, this phenyl ring is losing its aromaticity, and that is definitely is not going to be acceptable. So that's why bromobenzene, chlorobenzene, phenol, here this bromine, Cl and OH cannot live as a leaving group. They cannot form any carbocation, so they cannot undergo SN1 or SN2 reaction. Another example is vinyl chloride. We can take any kind of vinyl halide or vinyl alcohol. So here you can see chlorine group is present and chlorine is connected with this carbon. This carbon is sp2 hybridized. I have already explained that when a leaving group is attached with a sp2 carbon, the leaving group cannot leave and cannot form a carbocation. So vinyl carbocation is also highly unstable because it's already a sp2 carbon. That's why vinyl chloride, vinyl alcohol is not a substrate for nucleophilic substitution reaction. The key points whatever we have discussed till now, that if leaving group is attached with a sp2 carbon, it cannot form a carbocation, so it cannot undergo SN1 and SN2 reaction. The leaving group should be attached with sp3 carbon, then only leaving group will leave and form a carbocation, and that time this carbocation will be sp2 carbocation. SN1 versus SN2 reaction. So we have to understand when SN1 reaction will take place, when SN2 reaction will take place. So SN1 and SN2 reaction depends on stability of carbocation. If carbocation is stable, reaction undergoes via SN1. If carbocation is unstable or less stable, then reaction undergoes via SN2 reaction. Now here we can see there are different types of carbocation. This is 3 degree carbocation, this one 2 degree, this is 1 degree, this is methyl carbocation. 3 degree carbocation is the most stable carbocation among all these carbocations. So 3 degree carbocation, if the substrate form 3 degree carbocation, then it will undergo the reaction via SN1. And 2 degree, 1 degree and methyl carbocation, they undergo reaction via SN2 reaction. Here we have taken one compound that is called benzyl bromide. So phenyl CH2Br. So this position is called benzyl position. Now this is a leaving group. So if the leaving group leaves, we are getting benzyl carbocation, and here you can see this benzyl carbocation is primary carbocation. So that means we can assume that benzyl carbocation is a primary carbocation, so the reaction will proceed via SN2 reaction. But actually it's not happening, because this benzyl carbocation undergo resonance because it is connected with the aromatic system, and here the resonance of the benzyl carbocation has been shown. So that's why benzyl carbocation is highly stable carbocation. Since it's a very stable carbocation, so the reaction will proceed via SN1 reaction. So we have to remember benzyl bromide or benzyl alcohol, though they form a primary carbocation, but they are highly stable due to resonance. So this kind of compound undergo SN1 reaction. Now one more example we can use to explain that stability of carbocation is how much important for SN1 reaction. This is allyl bromide, CH2 double bond CH, CH2Br. So this carbon is sp3 hybridized, and this is leaving group. When the leaving group leaves, we are getting a carbocation. This is called allyl carbocation, but again this carbocation is a primary carbocation. But this primary carbocation is stable due to resonance. So that's why allyl carbocation undergoes reaction SN1 via SN1 mechanism. So the key points from this SN1 versus SN2 reaction is that stability of carbocation is the most important factor to decide whether the reaction will proceed via SN1 or SN2. If the carbocation is very stable, then reaction will proceed via SN1. If the carbocation is less stable, then it will proceed via SN2 mechanism. I think this video will be helpful to clear your concept, and if you think this is helpful for your study, then share this video with your friends. Subscribe my channel Chemistry Affinity. Chemistry related queries, you can send me a mail to chemistry.affinity@gmail.com. Thank you for watching this video.